Newnham, our other campus. Doug has been there since 1994. He's a professor of math and programming. I'll let you do the math, figure out how long it's been since 1994. He's an electrical engineer by training, honed his skills at IBM for, what did you say, about 10 years in the hardware side, many years also in the software side with databases. And what he really wants you to know is that he's now, in addition to all of this other wonderful experience, earned his gray hair as a grandfather. There he is up there. And I'm sure that Doug and I will agree that our respective grandchildren are the most wonderful.
That's right.
Wonderful people in the
That's
world.
right. Absolutely. All right. Thank you. Well, thanks for that. As you mentioned, I spent a long time at IBM before doing career switches here, and I just want to share with you how I came to do such a career switch from essentially being an electrical engineer and a manager, etc., within IBM hardware and software development. Because when I was in my 20s, I wanted to see the world, so I ended up taking a contract in teaching in East Africa, in Kenya, in Nairobi. And I did that because I wanted to travel, and that was a good chance to do so, etc., etc. I didn't do it because I wanted to be a teacher as such, or because I thought that even that would be any part of my career. And when I got back to Canada after that time, which was a great experience, by the way, I went into engineering at IBM, etc. But I do want to share with you that in your case, as you face your career, you will have probably more than 2 careers, such as I've had, and that whatever careers follow, it's very hard to predict what they'll build upon. So what you do, anything from sitting here today to anything else that happens by chance or by short term, may well turn out to be a turning point that later on in your life becomes an important tipping point that will turn you into a new direction or enable you to go into a new direction. So, now the time I've been here in Seneca as teaching, I've always wanted to increase and enhance the role of technology in teaching and learning. Partly because certainly in IBM I saw that technology was the driver of the business of IBM and of the industry as a whole. And yet I felt that its take-up or its penetration into the education world has been very slow relative to that of business. In fact, the analogy I make, it's much like in education, the challenge facing us about how to incorporate technology into our teaching and learning is about the same as faced the medical and health world a decade ago or so, when they were trying to, when especially government and others were trying to incorporate their use of computers into hospitals, etc., etc. And now they're slowly making that, not as quickly perhaps as many people would like. But you know now that if you go into your doctor or hospital, those are high-tech zones. Whereas in education, we've just made the beginning, right? We're using learning management systems, we're using technology in that way, but we haven't transformed the way we work and learn. So I created this, and I titled this Open System and Big Data, because I really want to talk about the information that we do generate as we use learning, like Blackboard, learning management systems. That information, which stores essentially what you have done or what I have done as a professor day to day, hour to hour, and yet it's data that essentially now gets flushed every year or so. It's not used in any significant way. You use it because in teaching and learning, you know, the documents that are presented, the grades that are presented as a communication platform come to you. I use it because it allows me to disseminate information in that way to you for your teaching, for your learning. But the question is, how do we make sure that big data becomes available, the benefits of big data become available to us and to the other wider society as a whole? Let me just make this full screen here, and away we go. So there are a number of partners or people involved in it. Obviously, what I call the builders, the people that create this big data. They are users as well, like you and I. There are also administrators and others that need that data or can use that data. There's a lot of people around that are essentially owning that data in the sense that they created the data, that they stored the data, that they used the data, influenced it. So they all have different views from an ownership point of view. And then finally, there's the free riders, the few folks that, the bad guys, or people that just want to use that data in some way that suits their purposes, maybe without, and with a negative against others. So, quick introduction. My definition of big data is just basically that. Huge amount of usually transactional data that's going to be stored digitally and in some kind of computer system up in the cloud more and more distributed. It obviously is data that spans time, over a period of time, accumulating, and place. And it has certain qualities. It's digital. It's there permanently in the sense that once it's stored, it's available and can be disseminated. But it's variable quality. It may be incomplete, that some parts of it got holes in it, and it may be noisy. It may have errata within it. So the analytics tool, which is what I'm really interested in, is how do we extract value from this? There was a phrase a few years ago called data mining, which was more about how to get data out of structured data, the transactions that are incorporated when you go shopping at your supermarket, etc. How to find the patterns that would enable the supermarket to make their products most valuable and available to you. So that kind of data mining to find what would be effectively more useful marketing information. But in general, what we're trying to do is find out the patterns that people have exhibited in that use of the big, or as they're creating that big data. Those patterns could be of use to the organizations that are providing that service, whatever it might be, education in our case. Or I hope, and what I want to talk about is how can we make that analytic information available to the people who are part of the system and make it beneficial to them. An example is in Blackboard. Blackboard today, we create about 2 terabytes of data in Blackboard because we store 20,000 students' data every semester, and probably every student in this room certainly at least 1 or 2 transactions per day on Blackboard, maybe many more, and that accumulates. So how do we make that available to me as a professor to improve my teaching, to you as students to improve your learning, and of course to others to improve administration, etc. So the objective is to find the protocols, policies, and standards that will allow us to both look at that data and analyze it and be able to make it available. Now to do that, we have to make sure that we don't let it leak, don't let it get out to the parts where it shouldn't be. And we need to make sure that it doesn't impact negatively or otherwise, either individuals or enterprises. And I'm going to tell some stories as we go along because there's been lots of cases where big data that was misused, if you like, or escaped in some way beyond what the people who created it either wanted or dreamed could possibly hack it. We're going to be in this whole question of how to use it is both a challenge about how to find these patterns and at the same time the right balance about not letting that data get misused. So we're not going to be able to have a silver bullet. We're not going to find a single way to have that future goal. We're going to have to evolve. It's going to be an evolutionary one of trying things and then learning from either the mistakes or the opportunities that occur when we try something new or innovative in that area. And I'll talk about a proposal that I'm trying to make here in Seneca to do just that in teaching and learning. Just go back to basics for a minute here. We can talk about information, data bits, at the level of the lowest level, just numbers, objects, learning, objects like images, etc. All of that is information that basically occurs. It's facts about the world, data bits. And basically that's what we think of as the lowest level, or should think of as the lowest level of data. The next level, and I've laid it in layers because basically you extract meaning, information from that. where you include not just the data, but the context. Where did this data come from? What was the circumstances under which it was created, etc.? What is the time? Some of the data is structured. Classically the SQL, the structured data, relational database structure of numbers particularly, though now being extended through XML to text. The information is also transferable. That is, when you have that information, you can then package it up. It's in human terms that you can transfer it to others. And it's reproducible. That is, you can essentially go back to find the audit trail of how it was created and how it was extracted, or you should be able to, in principle, be able to do that. All of this is that higher goal, the third level goal, is what I call human knowledge, even ultimately maybe something I might call wisdom, where basically you have models that allow you to look at this huge volume of data, this huge compressed information, and say this is a model for teaching and learning that would be different than what we do today. Right? We have a model for teaching and learning. It's the same basic model as Socrates had 2,000 years ago. Sage on stage, talking, raising questions, interacting with people, and conveying from them, from me, from Socrates to the audience as a whole, some level of insight into the world. But that's, as some of the other speakers, many of the other speakers have said, that's not the only model. Nobody learned to ride a bicycle by listening to Socrates, right? My grandson, 3 months old, is learning a language. He's not quite learning language, but in the next 3 months, he will start to learn a language. Not because anybody's teaching it. His mother talks to him in mother talk. Oh, maybe. Actually, it's in French, so it's even better. But his brain is going to incorporate that, and he's going to learn a language without any kind of teaching in the traditional sense. So how do we get from big data to models, what I call actionable data? In other words, information that flows up that we can take action on, that we can use in some practical sense. Because data that's just informative about how the world is not so useful as information that is about how the data could be, how the world could be. And then the final one, it has to be testable, in the sense that if we have a model, we should be able to extract and predict from it. So the analytics, the predictive analytics kind of thing, capability. So there you go, my 3 levels. In the area of analytics, this is more a model, and I've got this from one of my colleagues here in Seneca, where he essentially created this standard reports going back from the very, very beginning. I need a pointer here somewhere. No, I don't have it. Okay, well, I'll just talk to it here. At the lower level, in the old days, 1970s, right, computers produced payroll reports, and some payroll manager would read through that report and essentially make an information the companies now, the employees have been paid, and how often, et cetera, all the taxes are paid, all that kind of thing. If there was a question, Johnny quit on Friday, but we seem to have stopped payrolling on only the next Monday. What happened there? These kind of query problems. So these are the sort of classical, usually paper-based type of queries, usually structural or SQL, relational database type of information decision assists. But they did help managers in business and other areas make decisions that would improve their daily operation. If there was alerts, such as something has gone wrong or out of the ordinary, the budget is 10% above plan, and therefore there's a report that gets generated saying you need to take attention here, that sort of thing. But then, as the color indicates, we've got into what we would call now more predictive analytics, where not only can you have information, but that information can essentially indicate a future problem or a further opportunity, some area where you can do something bigger, better, faster, cheaper, perhaps, in a lot of cases. What will happen next? And then ultimately to control that. So in the case of teaching and learning, every day I face classrooms teaching, and I do things, I say things, I show things, I choose examples to work on, etc. I have no idea how effective those are relative to all the other opportunities that I might use to present. Should I show a video? Should I let students work on their own? Should I let students work together? I mean, these are all different ways of learning, and I don't today have much of an idea about how to compare or measure that. in any way in terms of learning effectiveness. Nor do you, right? Students don't really know at moment to moment how well they're learning. And they certainly don't know how well they could learn if they knew advantage of certain different ways of learning, interacting with the information, et cetera, et cetera. So there is going to be a transformation in the pedagogy, the way that we teach and learn. I don't think we're ready for it yet. We're still busy bolting on learning management systems to the existing system, as I'm doing here right now, right? I'm talking to, just like Socrates did. But later on, as we get more and more insight as to what actually happened in the learning, we can start to think about and transform that. So, who creates the data? First question. You need to always look at these things from a responsibility. Who's responsible, who did the work, and who owns it, and who is, if you like, liable or secure, who needs to worry about the security. So creating and processing and using the data, and managing and aggregating the data, because in a lot of cases this data by itself is not as useful as when it's combined with larger and larger data sets. So for example, teaching and learning, you know, Blackboard data is useful, but I also need to know, or at least we should be able to know, what about the students who go to the tutoring center? All right? Or what about the use of outside library resources, for example? Those are information items that might give a better understanding of that individual and that group's learning methods. So aggregation like that. It's also a problem in the sense that when you talk about aggregating terabytes of data, that's not a simple computational problem. It takes resources and it takes special tools, which we'll talk about a little bit later for the analytics. The understanding about the opportunities and threats, the threats part is, are there free riders, people that are going to make use of that? Now, free riders aren't people who are necessarily bad people. They could just be people that take advantage of an opportunity to do something that suits them, but at the results that it doesn't benefit anybody else or may even cost, if you like, the larger group. And then last thing is about the question of liabilities, unintended consequences. This idea of unintended consequences, by the way, it's not just that people don't think about these outcomes, or these negative outcomes, it's also that these are essentially unpredictable consequences that can probably only be found out by running the experiments, doing the work. I mean, I come from the hardcore engineering world where I know when you design a new system of any sort that there's going to be unintended consequences. A few of them will be good consequences. Oh, people can do this with that system. I hadn't thought of that or hadn't designed it. That can also be negatives. I mean, well, there are stories from IBM days where customers use products from IBM in ways that absolutely astonished us. You know, just, I mean, in some cases in very positive ways. This is Vincent Cerf, okay, who is the father, in fact, he's called the father of the internet, the seer of the internet, TCP/IP architect, because in 1973, as a graduate student in California, he essentially designed TCP/IP, and he did so in about 3 months, or 4, something like that, less than half a year, and then spent 10 years essentially using it to build code that would allow ultimately 3 computers, or 3 or 4 computers, to talk to each other across the world. And then in 1983, as this site says, basically, in 1989, it became the internet, or the network connecting other networks. That's what internet means, right? TCP/IP was really initially developed as a net of networks. Let me just bring up this podcast. Actually, what I'll do is I'll bring it up directly here, if I can find it. Sorry, wrong one. Excuse me. I knew this was going to happen. There you have to have full screen. So this was an interview in Montreal that CBC held with him, and that he basically talked about the future of the history of the internet. He now works for Google. He's has an incredible title. He's the future of the world, or something to that effect.
Evangelist.
The evangelist to the internet. So, very interesting phrase. Given some of our previous speakers, there's room for this kind of rhetoric in the world as well. I'm gonna jump into about this.
I would say that we weren't quite all the way around the world when we first turned the system on, but we were at least in Europe and the US and a little bit of the Far East. Of course, since that time, 30 years later, the internet has, as you say, penetrated very deeply in many parts of the world.
Were you an enthusiast or a naysayer in the beginning about the potential of the internet?
No, I was a huge enthusiast, and I still am, a great optimist. And my title at Google, which I didn't actually ask for, when I joined the company 10 years ago, they said, "What title do you want?" And I said, "How about Archduke?" And both Larry and Eric and Sergey said, "Well, you know, the previous Archduke was Ferdinand, and he was assassinated in 1914, and it started World War I, so maybe that's a bad title. Why don't you be our chief internet evangelist?" And I said, "Okay, I can do that." So I've always been optimistic about the use of this technology and its application. I'm also quite realistic, of course, that this is an infrastructure, and like all neutral infrastructures, it can be and is abused, and we have to be into that.
Okay, well, as chief internet evangelist, where did you preach it?
Well, anywhere that will listen to me. In fact, I remember being in Moscow, and I was asked in a public lecture, "Do you believe in God?" And I remember thinking that was a pretty personal question to ask. And then I thought, okay, I have an answer for that. I'm geek orthodox. And you know, everybody seemed to understand what that meant. So the honest answer is, everywhere I go, I try to convince governments and the private sector that investment in internet and its infrastructure is a worthwhile activity, one which will benefit many, many people, and I continue to believe that.
Well, explain a little more your gospel of the internet then.
Well, what is most important, I think, is that it offers this widespread platform which is openly accessible. It supports what we sometimes call permissionless innovation, because if you can get a connection to the internet, generally speaking, you're free to put any product or service up that you want, assuming that it's not illegal in the location where you are. And this notion of permissionless innovation has led to remarkable corporate developments. Google, of course, is a very large company, but it started out as two guys in a dorm room. The same could be said for Yahoo, the same could be said for Amazon, Jeff Bezos with his idea driving across the country. eBay, for example, and Facebook, another dorm room story. This system is so open. All the details, the technical information is freely available. You don't have to pay to learn how to be connected to the net or build systems to run an application on it. Look at all the apps on mobiles. It's another very open environment. So this openness and freedom of access to create, in addition to share information and to get information, from my point of view, is a stunning opportunity for our human civilization.
When did you know that the net was going to change the world?
Somewhere around 1988, after 5 years of operation, I walked into a big exhibit. It was one of these exhibition shows showing all this equipment that was interoperating using the TCP/IP protocols that Broadcom and I originated back in the early 70s. And I saw these huge displays, two-story displays from Cisco Systems, for example. And I remember turning to the then president of 3Com, Eric Benjamin, and I asked him, "Eric, how much do those displays cost?" And he said, $250,000. And I remember this is 1988, when $250,000 was actually a significant sum. And I just stopped dead in my tracks thinking, my God, somebody thinks they're actually going to make money out of this. Then I realized that up until that point, only government-sponsored researchers and the military had access to the system. And I thought that the government would not pay for every consumer's access to the network, so we needed to build an economic engine underneath it in order to support the spread to the general public. And so I became a big advocate of privatizing the internet and making it a commercial service. And some of my colleagues objected, saying, why would you let a great massive or launch people into into our sandbox? And my argument was, it's the only way that the rest of the world can get access.
So let me ask you, did it evolve the way you thought it might?
Of course, everything is happening exactly as we planned it.
So just catch that last key point there that he was making, that, you know, he made a decision to let TCP/IP protocol essentially be commercially available. And so stacks were built by IBM and many other companies very, very quickly, because he realized that was probably the only way that it would become global, because especially being a network of networks. So, you know, I know this is an open source and there's huge debates about how to commercialize or otherwise, but this is a strategy that at some point you can make that decision, because you can get tremendous leverage when you tie into the industrial economy. So let me now continue on here. I have one more sort of historical one, but first let me just keep going here. He's kind of a hero partly because, you know, he's got a great beard as well, so. Okay, let me just run through some of the, the thesis here is that, like any new emerging technology, big data and the analytics that go with it arouse a certain amount of imagination and creativity, especially amongst geeks, and some people otherwise who can see how they'll make money out of big data. But for every one of those, there's 2 or 3, especially in the media, that are looking for the stories about things that went wrong. You know, bad sounds in the night, things that went bad. So government is one of them. Government is a huge user of big data and a huge creator of big data. I mean, obviously they have as much information about you through your taxes and everything else as probably any other part of society. So the long-term census, for example, which was a debate point in the election 2 weeks ago, was reinstated, even though the previous government had decided that for various reasons they thought they would, I think they believed politically it would be wise not to have the privacy concerns of people who did not want to share their information with someone who knocked on the door and said, I'm taking a census for Canada. And that decision wasn't perhaps as serious as certainly they don't. I put this note in here, but analytics probably doesn't require it, because the reality probably is that the data that you need is equally valid whether you get 10% of the Canadian population or 95%. But more and more data is more and more reliability. So in that sense, this is probably the right thing. More data is better than others. Now the Liberal promise, one of the key points in their platform was open data. I haven't been able to find out anything more beyond that. I think the last thing, though, is that you're not going to be able to pick up the phone and ask the Canadian government for information about your taxes or whatever else. They're going to keep that and let that be your business. There will probably be revisions, though, or changes to the freedom of information. A specific example close to home here is this Toronto police debate going on right now about carding, where police can essentially stop anybody on the street and ask them some information, which is currently debated as whether that's necessary. The problem, of course, is how well do the police implement this detail, and do they do it with racial profiling? I mean, police have the responsibility to gather information about society and people's actions and behaviors, and what they do with that information, of course, is another issue, and how they get that information is being politically debated. So these are the areas that we talk about where there's a general need for the information to be gathered. We understand that, but there's some negatives that we want to have discussed and need to be discussed in an open forum or in a carefully, democratic way, I would say. Some stories about analytics and big data. So Target, I've misspelled it, I think it's Target, isn't it? Predicted a teenage girl was pregnant before her dad did. And this is an interesting story because the background while they're setting it up here, Targa basically collects data from people's shopping patterns, and they had run analytics which showed that under certain circumstances, women who buy, of a certain age, who buy calcium pills and I think it was large volumes of, not diapers, but something like that, they basically were most likely to be pregnant and were going to be parents very soon, and therefore Target would start to release targeted information to them that would indicate special deals for mothers to be. And I guess my link has changed since I last opened it, so I won't bother. The bottom line was that one parent came into the Target store, local store, and went to the manager and said, "Why are you sending this stuff to my daughter about, mother's clothes, etc.? She's 17 years old or whatever, and this is, you think she's a slut or something, do you? Or what is this?" So he tore a strip off the manager. The manager said, "Oh, I'm sorry, sir, I don't, that's okay." Anyhow, 4 or 5 days later, the manager called back, which is an interesting comment, that Target would have a follow-up on this kind of customer complaint. And the father said, "Oh, yes." He said, "Actually, I'm very sorry." He said, "There have been some things going on in my household that I didn't know about, and it turns out my daughter is pregnant." So, he felt that as a father of one, an audience of one, that they knew more about his daughter than he did, which is true. Now, Target took this lesson to heart, by the way, and they refuse to do very specific targeting now to mothers. They mix it in with other things. They'll put in, 2/3 of it will be, because they realize that people don't mind having, they find it, what the comment was, the Target advertising manager said, people find it weird that somebody would know something about me that I barely know. So they just kind of soften the message and appeal to the person's needs rather than a trigger saying, "Oh, I know you're going to be a mom soon, and therefore this is what you should buy from us." All right. When it was first came out, this story was more or less treated as, "Oh my gosh, they know more about his daughter than he knows." I mean, that is it. Ultimately, of course, marketing folks are using this information because they want to be able to sell things to you as if they know exactly what you need. They don't have to sell it to you, they just have to say, "This is what you need," or "Here it is," and know that you will accept it because you need it. That's every customer being unique, essentially. Or another way to think of it is they have branding that appeals to every single customer in an ideal, perfect way because they've tailored their information flow to you in a way that matches to what your needs will be, your wants and needs, in fact, probably better than you do. Marketing managers have always had this problem, right? I know that about half of my marketing dollars are effective in producing revenue. I just don't know which half. And now they can say which half more and more, or at least get closer to that approximation. Some example of data leaks, okay, the negative side of this. And let me share one with you from IBM. When I was in IBM in the early 70s, IBM for 13 years had an antitrust suit from the US Department of Justice against it for being a monopoly in the IT world, that mainframes, which IBM had 80% of revenue, were being dominant and were unfair competition. So IBM, with 150 or whatever number of lawyers, fought back for years, and they did so by essentially filing information that showed that IBM was competing in a way that was open and competitive. And the Justice Department said, to prove that, you're going to have to show us everything that you talk about whenever you have a customer kind of contact. And so IBM, I remember it very clearly, even in the lab where I was far from customers, we had to file pieces of paper. At that point, we were still a paper-based organization pretty much. We had to file all the information and store it if it was anything to do with customer relations. That was mountains. There were truckloads that were being collected. At the same time, IBM was using email, and so there was a huge volume of email being generated and stored. And IBM built a database that inventoried all this stuff. So every time a truck rolled up to the trust department, IBM had, some tape somewhere that indicated every single piece of paper with whatever was there. So anyhow, the trust suit under Reagan was dismissed finally after about 13 years. And as IBM was losing market share and therefore could say, "Listen, we can't dominate it, we're now 60% of whatever the market was." So it was dismissed. And about a day after it was dismissed, IBM purged all that data. They just, they dumped it in the bit bucket. And the trust department just went crazy. They said, how could you do this? Because they knew that if they ever had a hope of reinstating this trust issue, they would have to have access to that information, But IBM said, this is our data, this is our information, and, we've created it and made it available to you, but no longer. So that's an example of, how big data can, how do I put it, become a strategic and tactical weapon in the commercial world in particular. I mentioned copyright, trademark, and trade secrets. These are the traditional ways in which information is protected in the commercial world. They've always been there, and they've morphed into software, as we've heard in various other presentations here, being copyrighted and trademarked, and to some extent patented. I didn't put patents here as well, but now that's also possible. Information that has leaked out has been typically credit card lists. For example, recently I've forgotten the name of it, but some dating site had their website cracked. Does anybody know the name? Ashley? Any of you had your name on that list? Just raise your hand. Is it really? I did not know that. So as a result, there's been somebody who's embarrassed, nobody in this room obviously, or at least not going to admit it, that they were having a name on this dating site for whatever reason. So I mean, it was kind of a sort of a small information. I don't know if there's a class action suit against them or anything like that. Probably. Is it?
Government employees and government politicians on it.
Oh yeah.
It's like about cheating on your significant other, right?
Yeah. Well.
So
yeah.
it's pretty serious.
Yeah, because the reality is big data. I mean, the other example that occurs off my is the photo images that Google was taking, which showed people in places where they shouldn't be, kind of thing, or license plates in front of houses where nobody else thought they should ever be. Those kinds of things, were an embarrassment that Google had to take steps to, get rid of or image out, kind of thing. Medical data in the small, in the sense that information that, if you like, it's not about individuals' health. That would be highly protected. But information that just indicates that certain areas have a high rate of, infections, sexual infections, for example. I mean, these kinds of things, certain population, that kind of information which could come out of any kind of big data analysis. And then the last one, the big one, Edward Snowden, right, who blew the whistle by leaking thousands of pages and millions, perhaps millions of bytes of information about the CIA, including telephone messages of Angela Merkel, the German, and other chancellor, other senior members who were being spied upon by phone. And maybe the last one, Hillary Clinton has an email server that she's been using, which she thought was because it's her own, under her desk kind of thing, apparently, literally almost. But that was something that was her information that she didn't want to have part of the government press. And yet there's been a criticism that that's both risky and perhaps inappropriate. She's a public person, so everything she does should be public or should be available in the future. So we have these debates, okay, where people, they made the media has great joy because this allows them to print a lot of pages and distribute a lot of debate points. Tim Berners-Lee, one more video. This one actually is a video, and I've got it already open here somewhere. Yeah. So Tim Berners-Lee started, is the father of www.
Last year, here Ted, I asked you to give me your data, put the data on the web on the basis that if people put data onto the web, government data, scientific data, community data, whatever it is, it will be used by other people to do wonderful things in ways that they never could have imagined. So today, I'm back just to show you a few things, to show you, in fact, there is an open data movement afoot now around the world. The cry of Raw data now, which people made in the auditorium, was heard around the world. So it's roll video. Classic story, first one which a lot of people picked up, was when in March 10th, in fact, soon after TED, Paul Clark from the UK government blogged that, oh, I've just got some raw data. Here it is. It's about bicycle accidents. 2 days it took the Times Online to make a map, a matchable map. We call these things mashups. A mashup user interface allows you to go in there and have a look and find out whether your bicycle route to work was affected. There's more data, traffic survey data, again, put up by the UK government, and because they put it up using the latest data standards, then a user could just make a map just by clicking. There's a state of effect thing, so let's get back to 2008, look at Zanesville, Ohio. Here's a map a lawyer made, put it on a water pump, see which houses are there, which houses have been connected to the water, and he got from other data sources information to show which houses are occupied by white people. Well, there was too much of a correlation, in fact, between which houses are occupied by white people and which houses had water, and the judge was not impressed either. The judge was not impressed to the tune of $10.9 million. That's the power of taking one piece of data, another piece of data, putting it together and showing the result. There's some data from the UK now. This is UK government data, completely independent site. Where does my money go? Allows anyone to go there and borrow down. You can borrow down by a particular type of spending, or you can go through all the different regions and compare them. So that's happening in the UK. The UK government data, yes, certainly you can do it over here. Here's a site which allows you to look at the recovery spending in California, and take an arbitrary example, Long Beach, California. You can go and have a look at what recovery money they've been spending on different things such as energy. In fact, this is a graph of the number of data sets in the repositories at data.gov and data.gov.uk, and I'm delighted to see a great competition between the UK in blue and the US in red. How do you use this stuff? Well, for example, if you have lots of data about places, you could take it from a postcode, which is like a Z+4, for a specific group of houses, you can make paper, print off the paper, which has got very, very specific things about bus stops for things specifically in the EU. Larger scale, this is a mashup of the data which was released about the Afghan elections. This allows you to set your own criteria for what sort of things you want to look at. The red circles are polling stations selected by your criteria, and then you can select also other things on the map to see what other factors, like the threat level. So that was government data. I also talked about community generated. In fact, I edited. This is the wiki map. This is the OpenStreetMap terrorist data I actually put on the map. It wasn't on the map before TED last year. I was not the only person editing the
This is
OpenStreetMap.
fantastic.
Each flash on this visualization put together by an IT World shows an edit in 2009 made to the OpenStreetMap. Let's now spin the world during the same year. Every flash is an edit. Somebody somewhere looking at the OpenStreetMap and realizing it could be better. You can see Europe is ablaze with updates. Some places, perhaps not as much as they should be. Here, focusing on Haiti. The map of Port-au-Prince at the end of 2009 was not all it could be. Not as good as the map of California. Fortunately, just after the earthquake, GOI, a commercial company, released satellite imagery with a license which allowed the open source communities to use it. This is January time-lapse, people editing, that's the earthquake. After the earthquake, immediately people all over the world, mappers, who wanted to help and could, looked at that imagery, built the map, quickly building up and focusing now on Port-au-Prince. The blue is refugee camps these volunteers are spotted from the air. So now we have immediately a real-time map showing where there are refugee camps. Practically became the best map to use if you're doing relief work in Port-au-Prince. Witness the fact it's here on this dominant device being used by a rescue team in Haiti. There's the map showing on the left-hand side there that hospital, actually that's hospital ship. This is a real-time map that shows blocked roads, damaged buildings, refugee camps, and shows things that are needed. So, if you've been involved in that at all, I just wanted to say that whatever you've been doing, whether you've just been shouting raw data now, you've been putting government or scientific data online, I just wanted to say something to say thank you very much, and we have only just started.
Only just started. That's a key point. I mean, he's talking about community data and government data. I mean, when we talk about establishments like Seneca, we haven't really just started, but we should be. One thing, by the way, look at the labels on this guy's, his OMKB, talk about alphabet soup, eh? Does anybody know what a DFBCS is? I'd like to know, that's one I don't know. DFBCS? So, however, I am not taking away from it. I mean, he's an incredible person. Education and big data. Talk about government, community, open systems, if you like. Learning management systems, as you know, log data, right? Mostly they log data that's in the grade book, but they also log transactions. When you open a document, when you log on, all that information gets time-stamped and kept. And around 2 terabytes here at Seneca. And it includes obviously assessments where you put in marks, etc. Now, in the math course that I'm teaching, which I'm using a Pearson textbook, the textbook is, first of all, online, electronic copy or PDF copy of the textbook, but more importantly, all the problems, if you like, are also available online with Pearson software that through Blackboard essentially checks the answer of a student. So when I teach, I don't teach very much lecturing anymore. Basically, I have a room full of students at computers, and I'm pleased to report that 90% of them, 95% of them are busy learning with solving math problems, as opposed to a lecture room where maybe half of them are there and the other half are listening and the other half are not, that sort of thing. So just observationally, the learning rate is at least maybe twice to 5 times higher than it would be in a classic situation. Aside from which, math, as you all know, is like bicycle riding. You learn it by doing it, not by listening or watching people solve problems. The transactions that I get, and I'm going to show you a little later about the information that I get back, is how long did students spend on each problem. And they get immediate feedback. They can try the problems as many times, assignments they can solve try as many times as they want. So, I mean, 100% experience in learning, positive learning. Oh, here's a typical example from Gradebook. This is now more or less what I've downloaded from Blackboard some period of time. Notice that I did a low-cost way of just stroking out the student numbers there, because we need to be very careful here in Seneca. There are people that would yell at me if they saw this, or here in Seneca, that would yell at me from a security point of view. You can't show those numbers to anybody, but I've taken away the identifying information. And if you can memorize all this in the next few seconds and correlate it, you could probably go back and find out who those people are, etc. But you're not going to do that. Pearson has this test report, which is very good, but what's different about it is if you look and see, identify integers, rational numbers, it's not about the problems that have been solved, it's about what are called mastery points, sort of small topics, learning outcomes. And those are how the whole course is organized about these. It's not about just solving a problem or reading a chapter, it's about mastering these particular mathematical capabilities. This is a first semester one, so most of you will find that pretty simple. Identifying integers, right? Everybody knows what an integer is. Everybody knows what a rational number is. And so there you go. You'll know all that stuff, right? But to prove this, students have to do some number of problems and get this report as a result, which I can then use to very easily show what topic areas have not been mastered. This is a dashboard that Pearson also provides, which I find totally useless. I don't know how to read this. I don't know what it means. It's completely, but it looks good, right? Here's the grade book, and here's where, well, more importantly, it shows past due and how individual students have done. Here's a list of, from a planning point of view, for lesson planning, the various topics and where they came from in the textbook, how many problems there were, etc. in each one. So the point about all that was that there's not as if these learning management systems don't produce information. They do, and they feed it to me, and in some sense also to students. But it's not optimum. It's not actionable data. It's not something that I can either quickly look at and use in my everyday teaching, very easily at least. So my proposal is an applied research project where in fact we start to develop feedback methods and feedback reports, analytics, that would be actionable. One specific one, for example, in the first quiz I gave in the math course, I always do a reverse roll call, essentially roll call, and anybody who's not there, I send an immediate email from Blackboard. And I say, hey, you know, you're not been in quiz today or missed today's assignment or whatever. Is there something that when I first did it, I thought, well, you know, what's going to happen? But I had 2 or 3 students who came back and said, oh, sorry, I didn't realize, or I forgot, or I'll be there, or I'm still in China, in one case, somebody said. So, but I realized students can. Now, do I know that if I did this consistently, it would have an impact on the grade point average? I don't. I mean, I'd have to accumulate this data and practice this. Not only me, but we'd have to then compare it with people who didn't do that and see if we could identify it. But analytics could do that. At the end of a year or two with thousands of people, 20,000 students, some of whom get emails and some of whom don't, the analytics tools could start to correlate the outcome of grade point, for example, with that, I believe. That's what we want to prove. MOOCs, we've had a lot of information about MOOCs from previously today. I don't know if you were all in that presentation. I found it with the EDX presentation particularly. But what I found interesting in this and why I'm bringing it up here is the MOOCs, the Harvard and MIT group produced a data set from their experience. And this is the database, 640,000 records. So that is every student that took, I guess in that year, whenever it was, took their course from MIT or EDX, and they have published that. But they've done so following a set of standards that meet the US, what they call Family Protection, what's it called here somewhere? Family Educational Rights and Privacy Act, FERPA. All right, and it involved things like de-identification, simple things like obviously it took out names and any student numbers and randomized them. They removed information such as, for example, if less than 4 students took any 2 courses, if there were 4 students in this course and took 4 students in that other course, there's a test statistically that allows, if you looked at the whole set, to extract and identify those 4 students. So they essentially set the standard at 5. So any group that has less than 5, and then they looked at those 4 students or any other, and they essentially removed them as a way. I didn't understand it all. I mean, I looked at the methodology. Aggregation, they basically combine these in ways that are group surveyed. What they call blurring, I don't know what that is, but they've documented all this, and in fact, you can go there and we could use those techniques and meet that standard and publish this data. Why would they publish this data? Well, because they could, first of all, and because they want to encourage openness of the data without risking, personal identification or misuse of the data. Because this MOOC this kind of data is valuable in evaluating the effectiveness of MOOCs, the distribution, etc. I picked this one up. This is just a little screenshot here because it says, by using this site, you agree to the use of cookies for analytics, personalized content, and ads. So this is one way to let users know that data is being gathered about them and get them habituated to that. Most people, when they see this, they think, oh, okay. But if you ask people just in abstract, is it okay if we collect information about you, especially if you ask students, they'll say, well, I want to be compensated, or, can I, maybe not, I'd rather not. But in fact, this kind of makes it part of the normal operation. Because let's face it, if you're in an institution like this, your information has to be collected in some sense because we need to be responsible for it. And we do want to make sure that you respect and understand, or that you know that information is respected and protected. The US-Canadian law is called PIPEDA, and it talks about how private sector organizations, not government, not institutions, not Seneca or educational institutions, collect, use, and disclose personal information. Well, they have a separate one, right? They have FIPA, Freedom of Information and Protection, okay, which is a more pervasive and talks about how individuals have the right to access information in government or anywhere else. And it's not clear to me how those two overlap, which is one of the problems here, because big data, to make use of it and yet follow these rules can be quite difficult, quite challenging. When I looked at these rules, I think man, I'm not sure, like when I present this, am I breaking FIPA or PIPEDA? I don't think so, but I'm nervous sometimes. I go back to my IBM days. In IBM, when I was there, obviously we had a need to protect our corporate information. So there was a structure, for example, there was a system of, every piece of information could be classified as IBM confidential. And remember, I was working in development, so we were working on future products that had incredible value to our competitors or to our clients if they got out early. So IBM internal, confidential internal use, or just IBM information that could be shared. And at the end of every day, we locked everything off our desks and put it in put it away. So that was, and I didn't like it at the time. I mean, that was in the 70s when information, hippies, etc. was, fell. I had arguments with my managers, partly because I always felt that the concern that information would get out was far greater than the cost of keeping it secret, because it takes time and effort to put this information in classified, etc. And I'm worried a little bit about the same thing happening in the education environment here, that we're going to be so restricted. As I've had conversations where I said, I'm trying to make this proposal, and I've had a few people say, well, you can't say that about students. I mean, what about if students want to have all the information that they had extracted? Is that something that needs to be done? Before they graduate, could student say, I want every record, other than my marks perhaps, to be deleted? I mean, that could be a debate we might have in the future. And FIPA has some information about that. It in fact says that students, that you have the right to see information, because after all, there could be errors. I mean, my son has had a credit card problem, and he's just now climbed out from under that and finally got a clear credit card record. So it took him 3 years, and he was happy to be able to do it in a sense. Open data, final point, because the goal is to get actionable insight from data sets, whether it's for, as Berners-Lee said, for community purposes, mapping, etc., but to do so without damaging individuals or society as a whole, in larger or groups in society. So I can't, it's impossible for me to lay out the architecture to get that goal without having it. But I think needs, first of all, to recognize we need to have security and access control rights for any people that can access this big data, with a need to know. In other words, if you need to know in order to do your job or learn better, then that information should be something that is available. And audit trail, so if there is a leak, we can learn from that by going back and finding out how did it happen, where did it happen, who did it happen from, etc. Encryption, that's a good technique that's very powerful. And then the simple anonymization, I hate that word because I can't pronounce it. Basically, removing individual information, because it's the group information in large groups, it's really the source of most value in these large data. Just an interesting article, there's an encryption, I forgot to get the reference here, but there's an article in Spectrum and some products out now that promise encryption somehow, not even the person who receives the data, it's encrypted until the final moment. In other words, if you could steal that person's ID and run a query, the data would be useless to anybody but the person who generated it. So I don't know how they do it. This was a little something about security that I found useful to remember. How to prove your rights from a security point of view to access information. Something you have, something you know, like a password, something you have, like a key, or an encrypted code on a credit card, and then something you are, which is the most, and those are more and more reliable methods of security. Retina pattern, voice prints, these are things that are available now and not commonly used. How do we do this at the group level? Well, I mentioned how IBM had this categories of information, so you knew how to treat IBM confidential, registered information, etc. And they had audit trails that managed all that information. And we need to start doing that as well in Seneca. Right now, everything gets kind of dumped into Blackboard and sits there without anybody knowing what level of detail needs to be kept private and not. the big hassle, and I just had a debate just before this meeting with one of our IT guys, because the kiosks used to have an Ethernet connection, so you could plug in and instead of using wireless. But they've crippled it. They've started, at least in Newnham, they've crippled it. And I asked, of course, I raised a ticket and said, why? Because occasionally, for performance reasons or just quickness, I prefer to access that. And he said, well, because it's a security risk. So I said, fine. How much of a security risk? And how much is that worth compared to the occasional time when I need that for performance, or if the wireless went down? You know, that's the benefit. So you need to answer before you cripple it whether or not that exposure is of greater risk than the benefit that I'm telling you about for me. And he said, well, we don't know that. I said, well, then you shouldn't take action to change it, in my opinion. Honeypots, by the way, I just threw that in for fun because there is a certain, honeypot means that basically you put something out that you think's attractive to hackers or bad guys in general, and then when they crack into it or try to crack into it, you have a record of how much risk there is for having it. There's a whole question about, you know, entrapment here. You can't legally, for example, set up a honeypot in certain circumstances because it essentially traps people to doing things that they wouldn't otherwise do. And then last one, independent and random audits and inspections of against the use, the transactions, and the data that went into the database. I just added this recently. There's a huge range of products available, both open, Hadoop and MySQL, for example, in repositories for data storage, and the relational databases, DB2 and Oracle, etc. Analytical tools, SPS and SAS. SPS is the IBM, I don't know what it stands for, socially something or other. So this is how you can run.
For the social sciences.
Social package. Okay. Do you use it by any chance?
No, I have used SAS actually before I worked.
SAS is the kind of industry leader. And then,
Just statistical software,
yes, yes, that's right.
so S stands for statistics.
First one.
Yes, well, SAS stands for Statistical, help me here, I don't know. Society for, basically it produces statistical, as does R. The R is an open source, and there's a talk tomorrow if you want to know more about it. I've used R, and it's powerful, but not so easy to use, and it doesn't have very good presentation, whereas SPS and I think SAS do as well. Because getting the data is one thing, and then presenting it in a way that's actionable and understandable by the end users is another problem.
Just for calculating like maximum, minimum, mean, something like standard deviation.
Oh yeah, yeah, absolutely. You name it, and it'll do either one of any of them do. I mean,
Just statistics.
no, just statistics. Yes, that's just statistics. But there's so enormous number of statistics, and the various K-tests that was mentioned, for example. These are all available, but how to make use of them and how to interpret them is not an easy job. I mean, there's an emerging profession called data scientists, who use these tools or can use these tools, and it's tough work. I've taken a course on R because I would like to improve my ability to use that. And then the last thing to learn.
How many liters of milk we have sold today? How many liters of milk we have to order for tomorrow?
Well, some of them can, SPSS has the ability to look at and essentially run queries where it comes back and tells you. The key variable here is the amount of milk and the dental visits. I mean, they can build that pattern if they have the data, apparently. They can do the kind of interpolations and correlations. They may not.
Like people buy milk more often. On Tuesday, people do not buy as much milk as on
Yeah.
Monday because
Yeah.
they purchase it on Monday.
Yeah.
So
Yeah.
on Mondays we order like certain amount.
Yeah. That's the value in the commercial world, yeah, very much so in the business world. And then learning management systems, which are evolving. They're about the stage which operating systems were in 1970. There's big ones, and there's all kinds of open source and for small ones and specialized ones. Most of them still, as far as I can see, essentially deliver the pedagogy or are built on the assumption that learning will be done as it was in the classroom before technology became available. That's going to change. Conclusions. enormous knowledge and value from the big data, whether it's education or government or whatever. It's hard work. I didn't talk about it, but I can tell you that it's tough work to look at the data, to canalize it, and to protect it as well. All right, there's hope. I would say that if 3 years from now, 5 years from now, this discussion would be boring, because it'll be taken as granted that the data we have is being mined and analyzed and valued and used to improve and revolutionize and change the way we do things, both teaching and in other areas, like selling milk on Tuesdays, maybe. There we go. Thank you. Any questions? Okay. Actually, we're supposed to quit at 5 because at 5:10 or so apparently. But quick questions, if any. I'm looking, by the way, when I make this proposal, I'll be looking for some co-ops or kind of grad students who are interested in building queries against the Blackboard database. That's part of the proposal that I'm trying to get through. If I'm going to be presenting it in about 2 weeks. If it gets funded, it'll start in January. So I'll be looking for, as I say, at that point, for folks that want to get into this data scientist area. All right, and you have my name, obviously, and I let you know many times. No questions? Okay, I can see you want to get to dinner. Thank you.